So today we are doing absolute value inequalities. This is day 6 of the chapter that we're on, chapter 2. If you want to add a little note, day 6. This is one of my favorite things to do. I think I like this so much because it has a fun little memory trick. You get to make up these 2 new words. I think it's great. So anyway, I will teach you the 2 new words in your vocabulary. You sound like a genius when you say them. Not really, they sound kind of silly, but they will help you remember what you're doing in absolute value inequalities, okay? If you check out the board, we are doing notes for the next 2 days. No, notes for the next 1 day, and then review Thursday. Like I said, I still haven't decided about Friday. I think this chapter's pretty challenging, so I hate to rush us through it. If you guys seem to be doing good, we might go ahead and quiz on Friday. If you seem like you need a little extra time, we might just use Friday as a review. I haven't decided, and I still have to talk to the other algebra teachers, so I'm not promising you anything. I put quiz on the board just in case, so you're ready. But don't cancel a doctor's appointment or anything for that. Does that make sense? I mean, don't freak out. I got a quiz. Because it might not happen, but it might happen. Just wait and see. Super fun, right? All right. So you should have this all in your notes. All right, so do you guys remember absolute value? It's like the bars. Okay, so when we are solving absolute value inequalities, so we have the absolute value bars, there's some sort of expression on the inside, you have to get that by itself first. Then we write 2 inequalities. You have to decide if it's an and or an or. And we write the 2 inequalities very similarly to how we wrote the 2 equations when we did absolute values last chapter. So you have a positive one, you don't have a negative one, okay? And then we solve them, and we graph the final answer. The trick is you don't see the word and or the word or in these. You have to come up with if it's an and or if it's an or. And the way you tell is the super fun memory trick. Here are the new fun words you're learning. Do you see the word and? I want you to now think of it as less than. If it's less than, it's an and inequality. What do you think the or is going to be? Greater. Very good. So if I'm looking at a greater than symbol, we're going to say greater. And we're going to write an or inequality. If it's less than, we're going to write an and inequality. You need to add those 2 words to your notes. That is the key to absolute value inequalities. The silly word than, less than, and greater. Do people actually? So number 1, we are looking at the absolute value of x minus 3 is greater than 4. But we're not going to say greater. We're going to say greater. And we're going to write an or compound inequality like we did last week. Remember the ors? So the first one is just like when we did these with equations. You basically think the positive, you leave everything positive, you're good to go. Drop the absolute value symbols. Okay? Now, here's where it gets a little different. You got to use your new or, and you have to remember to switch the way this guy's facing and the sign of this number. Okay? So, remember in absolute value equations, we dropped the bars, we made it positive, we dropped the bars, we made it negative. Same thing here, but when we drop them, the second time we flip the symbol and we make it negative. And I'll show you why after we do the first 2 examples. I just want to show you an example, and then we will sort of see if we can reason our way through it. Okay. How do I solve these? Add 3. Good. So the first one I add 3, I get x is greater than 7. Keep my or. When I add 3 on the next one, I get x is less than negative 1. Here's my graph. And there's my answer. Okay, number 2, same problem, right? What's the only difference? Now it's a less than. So I'm going to write the same thing without the absolute value symbols first. Then I'm going to write it with an and because it's a less than. And then the second one, no absolute value symbols. Switch the inequality symbol, make it a negative. You are going to solve this. So, what do I do? Add 3 to both sides. And add 3 to both sides. When I graph this, I want the x's that are less than 7 but greater than negative 1. I don't like when I like that. I'm going to do it old school. So I want greater than, not sure where I'm going to stop, less than, the part where they're both true, so right in the middle. Okay? And then my final answer, I'm going to write it as one inequality with 2 symbols and no and. Remember that way? How would I do it? Negative 1. Very good. What are your questions? Okay. I think the less than greater is great, but I want to show you why, okay? So what we just looked at, I was 0, right? So if this is 0 on the number line, let's say this is negative 2, this is 2. If I want you to be greater than 2 units away, where would you have to be? Yeah, greater than 2 units away. So you cannot get within those 2 units. Okay, that's why greater than is the or. If I am the 0 again and I'm like, oh, it's so cold outside, let's all huddle together. I want you all less than 2 units from me. That's when you'd all be in here. Okay, so that's why less than is our and when we're talking about distance. Greater is our or when we're talking about distance. Okay? Okay, before I do anything, what do I have to do first? Yeah, I need to subtract the 18, right? Yeah, so when you have to isolate the absolute value. So I need to subtract 18 from both sides. Okay? All right, this is going to be a fun one. Are you ready? This is a great tour. So I want to write the problem as it is, right? Then I want to write the problem again, switching the direction of the symbol, changing the sign. So when I graph this one, I'm going to subtract 3 from both sides. I'm going to divide both sides by 2. Same thing on the next one. I'm going to subtract 3. I'm going to divide by positive 2. They still have an or in the middle. Okay. So, I want greater than this guy, right? Or less than this guy. It's an or, so how many things need to be true? At least one. So where is at least one of these things true on my number line? Because the negative 1/2 inequality is still going on, right? And this one's still going that way. So to the left of negative 1/5, I have one piece that's true. In the middle, I have two pieces that are true. On the right side, I have one piece that's true. So where is at least one thing true?
What? That's two. That's both of them.
All real numbers.
All real numbers. Good. Now, can I show you a shortcut?
No.
Okay. I honestly, if this was me, I've been doing this for years, you know, I'm getting kind of old. I would have been able to stop right here. I knew it was all real numbers all the way back there. Can anyone think of how I would have already known? Yes.
Because they're all in opposite directions.
But I didn't graph it by then.
Oh. No, I mean like the signs, like one's less than, one's greater than.
Before I even broke it up into two inequalities.
Okay, remember.
Think about it. I knew it was all real numbers all the way back there, where I just put the squiggly box around it. How did I know? The negative 2 is a good. Yeah, I think you're on the right track. The left side is always what? Absolute value is always positive. So I am saying any positive number is greater than negative 2. Tell me a time when that's not true.
That makes sense.
That's always true, right? So you can go through the whole process like we did and realize that you have an or where it's overlapping. So everything on the number line is true for one of these inequalities. Or you could have saw that it's an or, right? Greater. It's a greater than a negative number. Even if it's 0, 0 is greater than negative 2, and any other positive number is still greater than negative 2. So either time, if you wanna try to catch it early on with a negative, you can. If you want to go through the whole process, you can too. Just at some point, realize it's all real numbers. Questions? All right, number 4. What should I do to start this one? I got to get rid of everything on the outside. So what should I do first? Subtract 2. Follow along, guys. Subtract 2 from both sides. Divide both sides by 6. So we have the absolute value of 3x minus 1 is greater than or equal to 2. Get rid of the lines, okay? So 3x minus 1 is greater than or equal to 2? Yes, I was waiting for someone to use my new favorite word, greater. Greater than. So it's greater than or equal to 2. Then what?
Then it's 3x minus 1 is less than or equal to negative 2.
Very good. So you got to decide and or. Then you swip the swip. What was that? I'm all into these new words. I can't stop. I was saying switch and flip. You swip. Okay, switch it or flip it, whatever you want to think of it as. It was greater than or equal to. Now it's less than or equal to. You change the sign. It was positive 2. Now it's negative 2. We need to solve these separately, graph it, see what we're working with. So, how do I solve the first one? Plus 1, plus 1. 3x greater than or equal to 3. Divide by 3. Divide by 3. X needs to be greater than or equal to 1. Or what? Add the 1. Add the 1. 3x less than or equal to negative 1. Divide by the 3. Divide by the 3. X is less than or equal to negative 1/3. When I graph these, negative 1/3 would be to my left. Positive 1 would be here. I want less than or equal to, so fill it in. And then on the right side, I want greater than or equal to. It's an or. So how many things need to be true? 1. Okay, so this is a classic or. We have two inequalities. They're facing away from each other. That is my answer. Either x is greater than or equal to 1 or x is less than or equal to negative 1/3. Okay? There is no fancy way to write ors. You got to write the word or. Questions? So 3 plus the absolute value of 4 minus x is less than or equal to 9. We need to subtract the 13 first.
Yes.
When you subtract 13, you get that the absolute value of 4 minus x is less than or equal to negative 4. Do you want to work all the way through it, or do you want to try to use the shortcut because I have a negative?
Oh, you're right, because all positive numbers are...
Does that mean we have to do the words?
So, you were right. This is basically saying any positive number, right? That's always going to be positive. No matter what you make x, that is positive. Or 0, right? So, positive numbers are less than or equal to negative 4.
No, it's not right.
Oh, that's not right.
Wrong.
Give me a positive number that's less than or equal to negative 4.
23.
23 is less than negative 4. No. Even 0. 0, it's not or equal to either. Give me a positive number that's equal to negative 4.
I mean, if you put negative 4 in the absolute value, then 4...
But you can't just add an absolute value. So what's going to work here for x?
No solution.
Nothing. You are correct. No solution. So we just did work in our head, okay? So yeah, if you want to work through this, you will end up, since this is a less than, you will end up with an and that has no overlap. Well, they would be colored in. And you would conclude no solution. If you want to work through it, go for it. I'm working smarter, not harder, okay? There are no positive numbers that are less than or equal to negative 4. No solution, be done. Number 6, final example of the day, then I'm going to give you your homework. What should I do? You can, whoa. You do not distribute over absolute value. You need to subtract the 1 first. So we have 4, absolute value, 2x minus 5, close it up, greater than 20. Now what? Divide by that 4, good. So we have absolute value, 2x minus 5, greater than 5. greater than 5.
You gotta take out the line.
Take out the symbols. What goes in the middle? What's that symbol? Great.
Oh, no.
Boo.
Wrong one. My
That's
bad.
a greater. And then what's my second inequality? This is the harder one. -5. Good.
Oh.
All right, solve these bad boys separately and see what happens. Hey, we're not done yet, so knock it off. Too chatty. Shh. All right, so we have x is greater than 5, or yes, back here you will get a 0. So 2x is less than 0. You just treat it like any other number. 0 divided by 2 is 0. All right, so I'm going to put my graph up top because I'm running out of space. So I have a 0 and a graph that's going to the left. I have 5 and a graph that's going to the right. Is it okay to have an or that's facing opposite directions? Yeah, so this is my solution. That x is greater than 5 or x is less than 0. All right, questions on number 6.
Questions in general.
All right, today we learned about what?
Man, read the title. Solve the absolute value inequalities. Day 1.
Very good. Today we learned
A great tour.
to solve. You were right. Absolute
Inequalities?
value inequalities.
Also, lesbian and grateful.
Yeah, you also learned 2 new words. Awesome. All right, here comes your homework.